In this video, I'm going to just go through some of those points and combine materials from different lectures that are related mainly to the alpine glacier. Related to the earlier lecture, obviously it's the slope also that would relate to the speed or the velocity of the ice mass motion, and also you can think about to what extent the radioactive decay, the kind of geothermal heat that contributes to the flow of the ice. So there are different factors which I will cover later on that I did not speak about in just the previous video. And here I made some adjustments and changed a little bit the structure of this alpine glacier. And I'm just going to cover these points that I put on the board already. So this is then alpine glacier, which means that it's going to be high mountain area from which the ice is flowing out. Now obviously this is all about a U-shaped valley that we have here, so that's how you can think about the structure. It's the U-shaped valley all the way. And then to speak about mainly the rock formations first, that basically where the ice is found. So we have these pyramidal peaks, which also are called the horns in many cases. So these are then obviously created by the ice. I just circle it like that. And also we can find these kind of like the come or tarn or these hollows where originally earlier perhaps ice was located. So these little armpits, as we know. So that's the come or the tarn over there. We can also think about then the bed of this old glacier, which will be in this case mainly hard bedrock, so things like granite, and that's why we will have some of these formations like whaleback and so on. Here I would also highlight in the first place, just speaking about the formations, the errat. So the errat will be that kind of ridge that connects the two pyramidal peaks. So that is this kind of ridge between the peaks. And then to speak more about the ice itself, or how the ice is going to be behaving. So there's an accumulation zone, which is the perhaps higher half of the whole glacier. There will be the equilibrium line somewhere around the middle, which we said will be changing or moving in its altitude depending on the seasonality. And also there will be obviously the ablation zone, so the whole lower section can go even further here. So this is all the ablation zone where most of the ice melting, disappearance of the ice will happen. Then speaking about the ice, so we have the glacier, we have tributary glaciers, so that zone over there which connects into the main channel is the tributary glacier right there. What else we can see is that there will be here this zone where there's a change in the actual shape or the pattern of the bed of the glacier. We said that this is things like granite mainly, so that kind of material that is hard rock. Now that behaves differently from a sedimental material. So here what will often happen if we have this kind of shape is that the whaleback or the roches moutonnées will develop. So this kind of very smoothened area. We can also say that the striations or abrasion will happen in this zone. So striations by the carving of the ice. But interestingly, we can think here about the development of this formation, because the melting of the ice will happen in the first or the top area, the top zone of the whaleback. Why? Because the ice will be having this higher pressure because of the changing shape of the bed. So that's why it's going to be squeezed together over here. and that will cause the ice to melt because of this phenomenon that ice is able to melt under a higher pressure, even though it's perhaps under 0 degrees of temperature. And on the lower, it is put here, but of course we can know the actual terminology here as well. So the lower section of the whaleback, there will be where refreezing happens. So this pressure eases, the ice can flow again easily, and that's where we have the plucking. So the ice will freeze to the rocks, and so the whaleback, and one end will be smooth and the other end will be very rough. So the ice will drag away pieces of rock and carry it with itself. Now, what kind of other rocks do we see here? We'll have different types of moraine, and firstly, lateral moraine will be that moraine that is located on the side of the glacier. Over here, perhaps, the side, that rock material that enters this whole chain through like rock falls. And this lateral moraine can be found also on the side of the tributary glacier over here. So lateral moraine will become what we call the medial moraine when the tributary glacier enters the main channel. So that is, as I put here, the medial moraine. Okay, so this black line in the middle, which means that there are rocks on the top or within the glacier, it's being carried. So that's why you can see these darker lines often on glaciers. Those are often related to the many sources, the many tributary glaciers. And what else can we see then in terms of the rocks? There will be endomoraine or terminal moraine here at the very end of the glacier. So that's where all this material that once was either medial moraine or lateral moraine is dropped by the glacier as it's melting. Now we can find more of these if there are different stages of climate change from the past. Then we can find more historical medial moraine and lateral moraine material that ended up as being the terminal moraine in the past. So we can just call it the paleo moraine over here, which will bury some of these lakes. So what else can we find then is the crevasses, which are cracks on the top of the ice, and these are related to the whalebacks very often. So this uneven surface is a sign that there might be the development of a whaleback under the glacier. And whenever we find whalebacks, we can assume that in the past there were crevasses whenever the ice was existing above the rock. So crevasses are going to be these deep fissures, cracks. And also we will find in the moraine, so these mills, swells, holes on the ice where the supraglacial, so the water on the surface onto the ice, can enter and become inglacial or subglacial meltwater. So moraines are going to be those holes on the top of the glacier that will allow the water to flow down. What else do we have here then? In terms of what happens with the meltwater, there will be the glacial lacustrine environment. So glacial lacustrine, lake, so that area that is related to the lakes, the moraine lakes at the end of the glacier. There also will be glacial fluvial environment. So glacial fluvial is whenever we have this braided meltwater channels on a plain. So this can be where we find the proglacial outwash plain, which we said would be called the sundur. And there will be the glacial marine environment. So whenever all this material is washed into the sea or the ocean, So all these sediments and so on enter the marine environment, then we will call this environment the glacial marine. What else do we see here is that different rock types will be developing. And I just highlight here that we have the till. The till is basically everything that is like the moraine in the very first place. That is what we call the unsorted material of sediment, sand, and so on, even rocks, pebbles, boulders. They can be this kind of unconsolidated, unsorted material be called the till, which becomes the tillite. So the tillite material as a rock, when this is basically going through the lithification process and becomes a sedimentary rock. We know that lithification would include the compression and the cementation, but diamactite or diamactite material would be a little bit different from the tillite because it will be something that is developed through some kind of sorting process, like the water would sort materials depending on their kind of size or weight. And altogether we can say that there will be a glacial tectonite material also containing this till and so on that is developing under the ice. So whenever the ice is squeezing this sediment, so in this case we definitely say that there is a sediment material between the ice and the bedrock. So perhaps over here we would say that this kind of glacial tectonite material will develop. What else do we have here is we said that these bars would develop on the bottom of the glacial lacustrine environment. So if we have a lake that is developing from the meltwater, and wherever the material will be carried in terms of like sand and so on, so rock materials will be carried in there by these meltwater streams. These will be having these layers, bars, depending on the seasonality. Also what we have here is the turbidity currents. So over here we say that this material will be washed down into the ocean very often, and as it's accumulating here somewhere we have this kind of shelf. Time to time, perhaps exactly because of the earthquakes that would happen by nature, there will be turbidity currents that would create turbidite material, which we know about. So that would be that very smooth, fine material that would create the rocks around Aberystwyth, and the laminite as well. So again, very smooth and fine materials would build up the bedrock that is developing here as sediment on the bottom of the ocean. Finally, I just want to highlight here we have ice rafting. So ice rafting we would have possibly what we have here from tributary glaciers and the kinds of the medial moraine rocks on the ice that through the iceberg calving would be carried further down into the ocean, and whenever this melts, these will drop